All right, here's an interesting problem. So given a string s, we want to check if it can be constructed by taking a substring of it and appending multiple copies of it. And so I guess the sort of straightforward way that I thought of to do this is to basically just so one thing to keep in mind here is that, like, if s is constructed by taking a substring and appending multiple copies, the first copy has to start at the start of s. And so whatever this substring is, the substring is going to start at the beginning of s. And so, like, at first I was wondering if you have to check through all possible substrings, but no, it's a very specific set of substrings. And that actually the set is the size of the length of s, or maybe -1. There could be an off by 1 error. But in any case, that really simplifies our problem, because there's only so many things we have to look through. Okay, so let's start this. So first we are going to import math, because we are going to use math. I mean that both literally and in the sense of the library. So let's start looping through the possible substrings. So for I in range, and what's the range? So we want to, so this range, I is going to specify the final index of the, here, let me write this out. I is going to indicate the final index of the substring. And so what's the smallest index that it could possibly be? Smallest index is actually 1, because I should be the index of this substring. Wait a minute, is this going to work? Yes, it is. No, because basically the substring later on is going to be s all the way up to I. And remember, this does not include the index I here. So we want to start at 1 so that the smallest value is just including the first index only. Because if we start at I equals 0, then this string is going to be blank. Because of the whole, this going up to index I minus 1. And so it would be index 0 minus 1, which is -1. Okay, so we're going to start at 1, and then the maximum is going to be, okay, so let's write it out and then explain it. Math.ceil, I'm going to take the length of s over 2 plus 1. Okay, so what are we doing here? So because the substring needs to appear multiple times, it can't be larger than half the length of s. And so that's why we use length of s over 2. But we use the ceiling function just because we want to make sure that we account for the scenario in which oh well, I guess we would actually want to use floor here. Although I'm sure you could prove that it doesn't matter here, that if it doesn't work all the way up to the floor, for the case where the length of s is odd, I'm sure you could prove that if it doesn't work up to just below the halfway point, then it won't, the integer below the halfway point, then it also won't work for the integer above the halfway point. But oh well, actually the next The next line of code will take care of this, so don't worry about it. So, but the point is we want to get an integer here, so that's why we use ceiling here. And then again, we add 1 because we want to account for that off by 1 error, because we want this string to go up to and include that index. Okay, so now the first thing we need to check is we need to check if I divides the length of s. And why do we need to do this? Because basically what we're going to need to get to in order for this to work is we're going to have to take the substring and we're going to have to like repeat it some number of times, and that's going to have to give us the string s itself. Okay, so in order for this to work, the length of this substring needs to divide s, the length of s. Otherwise, n would not be an integer here, and this wouldn't work. Okay, and that's how this is like division with remainder, and so then this is going, if I does not evenly divide the length of s, then there's going to be a remainder which is non-zero, and so this makes sure that the remainder is 0. And remember, so the length of s, I is the length of the substring, because it goes from indices 0 up to I minus 1, and so there are I total indices, and so the length of s is I. So if the length of s is divisible by I, then we also want to check if, what do I have? Oh, yes, there we go. N is going to be the length of s over I, which we have just shown that this is going, we know already that this can be expressed as an integer because of the fact that that it divides it evenly, but we use int anyways for type purposes, because if you just use division, then Python's going to make it a float, and we don't want it to be a float. We want it to sync. Anyways, okay, so next, if n is greater than 1, because we do have this edge case here where, does this apply? The length of s divided by I. I think there is an edge case where this actually does apply, and it's where I think the edge case is if the length of s is equal to 1, because then everything else works out. But then you run into this situation where, like, again, we need to take like multiple copies of the substring, and so we really need this n to be greater than 1. I think my gut tells me that there might be some simpler way to impose or to make sure that this is the case. Because, like, for example, if it is the case that the only edge case we need to check for is the case where the length of s is 1, then we would want to do that at the very beginning of the code so that we don't have to check this like every time we get to this line of code in the loop. But in any case, this is going to be fine. It's not a big deal. So if n is greater than 1, and now we can check if Sn times n is equal to s. I think we can get rid of all these now. Now in this case, then we return true. And if at the end of the day we're not able to make this work, we return false. Okay, so we have this huge sort of line of if statements because yeah, we have so many conditions that we need to meet in order, because this is the thing that we really need to check, is that we need to check that there is some n such that this holds. And the reason I broke it up like this was just to give like multiple opportunities to like skip over and not have to do this code. Yeah, this is how this code works. So yeah, this will work. And I actually want to start with this solution and type this out and then go from there. So import math for I in range 1, and we're going to go up to math, seal length of s divided by 2. We're going to add 1 because of the off by 1 stuff. If the length of s is evenly divided by I, then we want to keep going, and we're going to make n the integer that this division is. And if this n happens to be greater than 1, if the substring up to index I minus 1 repeated n times is equal to s, then we return true. No, we do not return true. Then otherwise, at the very end, we return false if that never works. Okay, and there we go. And I am really curious, actually, now that I had mentioned that thing. So if the length of s equals 1, we'll just return false. Now let's do this. I should not be coding on the fly, but here we are. Okay, yeah, it works. And it looks like, you know, when you submit your solutions, like if you submit the same solution multiple times, like this value will like vary. So I got a better value. I don't know if that's because of the fact that the code was actually better, or if that was just like randomness in the code running. But in any case, this works. So now here is another solution. So now let's restart it. I'm just going to build some suspense. Return s in s plus s 1 to minus 1. And it works. This is wild to me. And I don't have a proof of this yet. So basically, like, let's see, when I'm coming up with these solutions, I want to make sure that I'm covering all my bases. And so what I've been doing is, you know, of course, like I've been checking with ChatGPT, and ChatGPT came up with a solution, and I asked it for a mathematical proof that this works, and it gave very hand-wavy arguments, and so that leads me to believe that this example was just in the training set, but the proof of this fact was not in the training set. That's my hunch anyways. But also I don't know how, like, you know, emergent things from LLMs anyways. It's a whole other stuff. The point is, ChatGPT was able to give me this solution. It was not able to help me come up with what I found to be a mathematically rigorous proof of the fact that this works. and I tried looking it up, what is now the old-fashioned way of using like Google search and Stack Overflow. I came up to this, and let's see here. I got to here where like someone mentions that, a string consists of the same pattern repeated multiple times if and only if the string is a non-trivial rotation of itself. And someone else mentioned like, oh, I think this is mentioned, yeah, do you have references to the theorems? It's mentioned here as lemma 2.3. Okay. And here. And here's the lemma in the paper. And so like, this, like, let's see here. This is not a proof, is it? So to count the number of times. Yeah, because then we start talking about like the next lemmas following. So it's like basically like, oh, here are some lemmas that you should be aware of if you like are active if you read a lot of these papers, then these should be trivial lemmas for you. Then anyways, and then here they are like, okay, let's move on to other things. So they don't actually give a proof of this. They just state that it is a lemma. And so this is really frustrating. Like at least here they're like, this is, you can see this lemma in these other papers, whereas here it's just like, no. So, so I really, really, really want to get a proof of this, but I'm also sort of at a point where it's like, I need to decide what I spend my time on. And it's like, I don't know if I have the time right now to dig into this proof and come up with a proof of this. I really want to, and someday I hope to come back to this and make a video where I actually have a mathematical proof of this fact. But for now, we are going to need to be content with the fact that we have a sort of brute force solution that we can create on our own, and then we also have this sort of magical solution which works for some reason that I don't know at the moment. And so there we go. That's what we have for this exercise.